A pair of male and female human beings have moved from one position on the Earth's surface to another. Good day, kids! It's Molecular Matt, and I'm coming to you with a brand new edition of Science in the News! Our top story tonight: data from the Rosetta spacecraft has reignited the debate over the origin of water on Earth. Last month, the European Space Agency made the first controlled landing of a probe on an orbiting comet. In the weeks since, it's been analyzing the different types of atoms that make up the water vapor on Comet 67P, also known as this. What's really interesting is that the results were not what they expected. So much so that the previous model for the origin of water on Earth has been thrown into debate once again. The question of where Earth's water came from is hugely important, but remains basically a complete mystery. What we know is that when the Earth was first born, it was so hot that any water that might have existed would have boiled off. We also know that today, about 70% of the Earth is covered in water. So, where did it all come from? The primordial solar system was full of debris like comets and asteroids. The leading hypothesis is that our water came from these extraterrestrial bodies crashing into Earth. While that much seems clear, the relative contribution of comets and asteroids is what has been thrown into debate. You see, there have been 11 other missions to sample the type of water vapor on passing comets and asteroids. No matter where you are in the universe, water is made up of 2 hydrogens and an oxygen. However, the hydrogen can exist in more than one form. The first is just normal hydrogen. It's got 1 proton and 1 electron. The second is known as deuterium, and it's an isotope of hydrogen, meaning that it's the same as hydrogen except its nucleus contains a different number of particles. In this case, it has both a proton and a neutron, which means it is slightly heavier than regular hydrogen. Obviously, we know the concentration of deuterium in the water on Earth, so the goal is to find the type of extraterrestrial body that contains that same concentration. Of the 11 other missions, only 1 had found evidence of hydrogen with a deuterium concentration similar to Earth's. And that was this one right here, Comet 103P Hartley 2, which is a Jupiter family comet that was probed in 2011. Based on that information, 67P was expected to have Earth-like water, as it is also a Jupiter family comet. But nope. The results put this comet in a completely different class, with deuterium concentrations 3 times that found in Earth water. And so, where do we go from here? Well, this is actually pretty cool because we get to see the scientific method in action here. You see, before we had a hypothesis that the water came from this specific type of comet. Now that seems very unlikely given the new data. So we're going to take a look at other hypotheses. Take a look at these possibilities like this group of asteroids here, which as you can see has a very similar deuterium concentration as Earth. But it was ruled out in the past simply because asteroids are much smaller than comets, they contain much less water, so it would take a lot more of them to bring all the oceans to the Earth. But at this point, this looks like a more likely possibility. The really cool thing about this mission to 67P is that the data on the water is just the beginning. Rosetta is going to follow the comet on its orbit around the Sun throughout the next year, continually studying the chemistry and physics of this thing. We are going to find the answers to questions that we didn't even think to ask. Well, that's all for now. This is Molecular Matt signing off. We'll see you next time for more Science in the News.